All right, my friends, welcome back to Profit Stats. Okay, Chapter 2. We're on Chapter 2.2, which is going to talk about quantitative variables. Last time we talked about categorical. This time we're going to talk about, of course, the quantitative side. Okay, so that includes a couple of new things, but a lot of the same something that we talked about with the categorical ones will carry over. So make sure to have that practice. Here are our objectives for today. Okay, we've got the idea of explanatory and response variables coming up again, but this time for quantitative. That's a 1 point here. We've got this idea of a scatter plot, which I'm sure you're familiar with. Okay, something we've probably seen a little bit in our mathematic career. Okay, and to display the relationship between two quantitative variables there. And finally, we're going to talk about how to analyze that scatter plot. Things like direction, form, and strength. Okay, describing a relationship, and also identifying the outliers in a graph, a scatter plot graph. All right. With that being said, let's go ahead and get started. Okay, I'll be annotating in white when I deem that necessary during the notes, so please make sure to follow along here. And of course, remember to think about the Edpuzzle questions as they come in. So first of all, let's go ahead and talk about the scatter plot itself. Okay, we already know what explanatory and response variables are, so it doesn't really make sense to start with that again. So let's talk about our scatter plots. Okay, when you compare two quantitative variables, the best way to display that, okay, you can display with many different things, okay, but scatter plots are the best way to describe that relationship, to display the relationship here. Okay, and so we're talking about, surveying the same individuals for two different pieces of quantitative data. Okay, and that one person giving us two variables, two different data types. Okay, will allow us to graph it, more traditionally, one on horizontal, one on vertical. Okay, so think about this idea: if you have two variables, one's dependent, one's independent. Okay, remember that from maybe algebra or pre-calc, something like that. If you've taken those classes, this is kind of the same deal. Okay, and each individual in your data appears as a point, an intersection of the two axes. Okay, so just like graphing in algebra or pre-calc, you're going to have a value, okay, on the horizontal axis and a value on the vertical axis, and where they overlap causes a dot to appear if you see that in the individual's collected data. So let me show you an example. All right, here's our example, first example of a scatter plot, a very basic looking thing. You can see it's a scatter plot because instead of a line or any sort of shape like you would see in algebra, geometry, pre-calc, you actually just see a bunch of dots, okay? So what I want to highlight here, okay, is that this is a scatter plot showing the relationship between the weight in carats and price in thousands for 95 different diamonds, okay? So each diamond, okay, in the study has given us two parts of the data: our weight in carats, okay, and our price in thousands, okay. Now, when I look at diamond A and say, okay, it weighs this much and sells for this much, okay, then I know where to plot it on the graph based on my two axes. Okay, so let's talk a bit more about those axes here. On the horizontal, usually you know this as the x-axis, okay, but in this case, we are not going to try and think about it as x or y, okay, although when you make scatter plots, it can definitely be helpful, especially when we talk about the different types of variables. Okay, but as you can see here, there's a lot of dots down here. They kind of stack up together, which is totally normal, okay, depending on what you're talking about. In this case, we're talking about diamonds. So, of course, diamonds down here that weigh in the 1 to 2 range, they're probably going to sell for the same amount or so, depending on who you ask, okay, but obviously the ones that are heavier sell for a little bit more, so on and so forth. But once you get to the higher numbers, they're a little less frequent. Okay, they're rarer to find, and of course, since they're rarer to find, they sell for a lot more money. That's how this graph was made. Okay, we don't know all the 95 data points or the tables for it, but this is the plot that they gave us in the examples. All right, so now we've talked about and looked at a scatter plot example. It's time to move on to response explanatory in terms of the quantitative. So we talked about this with categorical. Here are the definitions again as a quick reminder. Okay, a response variable is just a variable that measures an outcome of a study. Could be anything really. Okay, while the explanatory one is a variable that may help explain or predict, okay, the changes in the response variable. So it causes, not causes, but maybe predicts, okay, or allows you to predict the outcome of a another variable, the response variable. So let's go ahead and practice with quantitative here. Okay. The examples of explanatory and response variable, please identify the explanatory variable in the two examples. I'll do the first one and I'll let you do the second one via Edpuzzle. In the first problem, problem A, I've got average income and life expectancy in a sample of countries. Okay. So when I take a look at this problem here, there are two variables. That would be average income is variable number 1. Okay, I'm going to call it as number 1 here. And life expectancy, which I'll double underline here, that's number 2. Okay, that's my second variable. Now, if you're talking about, well, what is the sample of countries part, then this is our individual. Okay, I'll abbreviate it as individual. Okay, so who am I sampling? I'm sampling some countries. What am I sampling from them? Average income and life expectancy. So out of the two of those, which one would I pick to be explanatory or response? Well, I guess you could say typically that if you make more money, you probably can afford better health care. Okay. Or maybe you pay more taxes. Okay. So maybe you don't have a longer life if you do that. Okay. But typically, your life expectancy is dependent on, at least in part, how much money you make. Okay. Of course, if you don't make a whole lot of money, you might not live as long, especially if you're not fulfilling those basic needs. That's like psychology and stuff. So that kind of overlaps. So I'm going to go ahead and peg that number 1 is my explanatory, okay, and number 2 is my response. Let's go ahead and take a look at the next slide and see if I was right here. All right. In here, I say the explanatory variable is the average income. Average income. Yep. And it seems like I was right on the money because the amount of money people have to spend on healthcare explains the average lifespan of the people in a country. Now, I'm not sure I agree with the reasoning here, but I think based on intuition in the current society, if you make more money, you pretty much have a better chance of living longer. You have access to better technology. You got access to better, healthcare, I suppose. Okay. But that's kind of just the example here we're going with. All right. So average income, explanatory. That makes our life expectancy the response. All right. So go ahead and take a look at number 2, part B. Okay. And I want you guys to think about which one you would peg as the explanatory or response variable. It's going to compare heights of husbands and heights of wives in a sample of married couples. Go ahead and take a few minutes to try this out. All right, and if you tried that out here, here is the answer for you. Okay. Part B, the explanatory variable could be either heights or wives, okay, because either variable could be used to explain or predict the other. Now, just like with categorical, so if you picked one or the other, sorry, it was kind of a trick question, okay, but because just like categorical, there are some cases where you won't be able to identify, okay, which one is clearly explanatory or response. Now, I think unlike with the categorical one, okay, where I think it is definitely more concerned with which one you pick, since the whole idea of a segmented bar graph is based on whichever one you pick as the explanatory. Scatter plots are a little more flexible in this idea, and we'll get to that in a sec. Okay, but for this problem, okay, book says could be either or. Okay, they could predict the other's outcome, but typically those things don't really, hard predict or hard influence the other data collection there. All right, so let's talk about our scatter plots. Let me clear my board so you can actually see what's going on. Okay. But how to make a scatter plot? We're actually going to do 3 different steps. Okay, very simple. Again, I'm not going to ask you to do it on Edpuzzle here. We'll definitely do it in class. Okay. But step 1 is to label your axes. The explanatory variable is usually the one on the horizontal axis, and the response variable is usually the one on the vertical axis. Okay. And of course, if you can't determine one way or the other, you can always pick either or. Okay, it doesn't have to be limited to one or the other. And this is what I was talking about when I said if you can't determine the explanatory variable, it's not a huge deal because the axis is, you can flip them. It's kind of okay. Part 2 is scaling the axes. Now, unlike a regular graph, which you might be doing with like in Algebra 2 or pre-calc, okay, you don't necessarily have to start at 0, 0. You just put the names of your explanatory variable and, a response variable on the axes to label what they are, and then place equally spaced tick marks and start at a friendly number. Okay, a friendly number. Now, what is a friendly number? Okay, I'll take a look at an example later, but basically it could just be any number that's right below your minimum. So it doesn't have to be 0. It could be like 60 if your minimum is 60. Okay. It could be 50 if your minimum is 55. Things like that. Okay. And of course, you're going to do the same for both axes, depending on whichever you pick. Okay. So your graph is going to look a little different, definitely, from the typical Cartesian coordinate plane we work with in the earlier math courses. Finally, we just plot those individual data values. Okay, and we'll talk a little bit more about this a little further down the road, but that goes without saying. Once you get your graph made up, it's time to just put the values in as dots, and I think that makes a lot of sense. All right, so here's our quick example. So here's our 40-yard dash time and long jump distance for a small class of 12 students. So again, my individuals is this class of 12 students. I'm taking 2 pieces of data from them, 2 surveys. One is their 40-yard dash time. The other is their long jump distance. Make a scatter plot to display the relationship between 40-yard dash times and long jump distances. And here's that data for you right here. Okay. Now, I'm going to go ahead and put the graph up. I'm not going to really spend a lot of time graphing it myself because that will cut into the video time. We can definitely do that during class. So here's the actual graph they came up with. Okay. We can see it nice and easy. Let me get out my draw tool so I can help you label them out. Okay. But basically here, well, I guess you can see this, but that's all right. Okay. You've got 2 ideas. Okay. You've got this long jump distance, which I'll call LJ distance, LJD, and dash time. Okay. Which it might be easier to see as something like this. Okay. If you really want to put it that way. But either way, okay, you can kind of think about this as being an X or this as being a Y or vice versa. In this case, they chose to put dash time as the X here, right? If you want to think about it that way, and LSD as the Y. But again, it doesn't really matter as long as you've picked whichever one is the explanatory. Now, for this one, they picked explanatory as dash time. So they'll definitely be using this as the X. Okay. But when they see it, okay, dash time 5.41, okay, and long jump distance of 171, these 2 values are tied together. Okay. So when you see these 2 in the columns lined up, those make up one data point. That's what you put on the graph. If you want to locate this one in particular, I'm going to look at 5.4, which is about right here. Okay. And I'll go up to 171, that's about right here, and there's my dot describing this data point, this individual. Okay. So I think it's pretty straightforward. You guys have probably seen this before. Okay. If not, though, this is a little refresher, okay, or some new stuff for you. All right, and finally, we're going to talk about describing our scatter plots. This is the last part of the lesson here. Okay, we're talking about 4 different characteristics of scatter plots, okay, but they all have to do with association. Okay, so remember that from last time. Okay, it'd be nice to remember that and bring it forward to the front of your brain here while we talk about this. Talking about direction, form, strength, and outliers. Okay, so again, we're going to come back to the idea of outliers here, okay, but it should be pretty straightforward this time. First up is direction. When you're describing a scatter plot, okay, you may have noticed it earlier in the lesson, but the dots tend to go in a direction when you read the graph from left to right. Okay, and we can associate them 3 ways, 3 main ways: positive association, negative association, and no association. Now, when we're talking about this idea of positive, negative, and no, okay, you just got to remember we're reading from left to right in this country anyway. So when you're talking about positive association, you're going up as you go from left to right. Okay, think about positive slope as well. Whereas negative association, you're going to be going in the opposite direction, downwards and to the right. And finally, if you're no association, that pretty much means you don't really have a line or a trend to talk about. That's if your dots are all over the place and no particular cluster is really standing out to you. So if we take a look at our example with the dash time and long jump distance, okay, I think it's pretty clear, to me anyway, that I have a line going down and to the right, which causes this to be a negative association in terms of direction. Okay. Negatively associated dash time and long jump distance. Okay. And the same thing would happen even if you flip the 2 axes, okay, just so you know. Because if you flip this to be on the other side, all that would really do is you reverse the positions of the dots. and that pretty much would make the same shape. All right, next up is form. Okay. And now in form, it's two trends, so similar to direction, okay, but we're talking about linear versus non-linear. Now this one should be real easy, okay? Real easy. If you remember that first one we talked about, that diamond one, okay, it kind of had this curve where it was started okay, and then it kind of curved up. This would be an example of non-linear. I guess I should have moved it down there. Give me a sec to actually move it there, in that case. There we go. And then let me delete that one. Okay, and draw a new one for linear. So in this case, we've got the nice downwards trend. Okay, even though the dots don't match up to a line, you could probably, fit that data to a line. So we would call this graph about dash time and long jump distance as linear. But that diamond problem we saw at the beginning, something like non-linear, since we're not describing, straight increase one-to-one, but more like a gradual exponential growth. Next, we'll talk about strength. Okay, now this is again talking about association. So far, so good. We hopefully have been remembering associations throughout the whole lesson here. And we've got some example descriptors, but I do want to let you know that they're not typically the only words you can use. This is English after all, and they have plenty of synonyms. Okay. It is more of a spectrum here, where moderate would be they're pretty close to whatever you choose to model it with, weak being they're not very close, and strong being they're pretty close. So again, going back to this example here, I'd probably say it's moderate. If you drew a line to kind of fit this data, you probably see them all about the same distance, but they're not super close. That would show us a moderately strong association between the two variables here. Now, if we go back to that diamond one, you could tell at the beginning there's a bunch of clusters. That's a pretty strong association, at least at the beginning there. So that's what I would call that. All right, and last but not least, we have the outliers. Okay. All right. So just like in the other, sorry about that. Just like in the other topics we talked about outliers with, okay, we're just looking for points that fall way outside all these other descriptors. Okay. In our example here, we don't have any because if you draw a nice straight line cutting through it, most of the dots are pretty close, or at least the same distance away as the other dots on the other side. So there aren't any outliers in this one. But I'm going to show you an example of one that does have outliers. Here you go. Okay. I just grabbed this from the internet. A scatter plot of weight versus height. If you do the trend here, it kind of looks like a linear, possibly non-linear, depending on how you interpret it. Okay. But it's definitely a positive here, going up. Okay. And there is an outlier. It is up here. Okay. This person isn't very tall compared to the other people in the study, but they're very, very much heavier. Okay. And they must be an outlier because they don't really follow the trend of this graph. Okay. So with the scatter plots, outliers should be real easy to spot. If you think they're out of place, they're probably an outlier. But if you think they're pretty close to the shape, they probably aren't an outlier. Okay, use your judgment on that one. All right. So, at the end of this lesson here, I've gone on a little longer than I needed to, but did you meet the objectives? So, these are the objectives again from the beginning. Distinguish between explanatory and response variables for quantitative data. Okay. Make a scatter plot to display the relationship between two quantitative variables. We'll practice that in class. And 3, describe the different qualities of the association in the relationship: direction, form, strength, okay, and also identify your outliers. If you think you can answer all of those, at least to a little bit of your understanding, then you'll be prepared to talk about it in class next time. So I'll see you then.